Hey guys, and welcome to another video on Efficient Python. In this session, I want to take a look at one of my favorites, which is list comprehensions, and we'll jump straight in with an example. So suppose we've got a list of words here. I've just done some random stuff that's on my desk, and I've got a blank list called longer than 4. Now what we want to do is say, for each word in this list here, if the length of that word is greater than 4, then go and append it to this list here. So if we hit run, there we go. We get apple, cheese, and coffee because they're longer than 4. And you could argue that this is a fairly common situation in Python. We quite often have to iterate over something, ask a question about each item, and then put it somewhere else. Maybe you're passing through numbers to find evens. You could be iterating over a list of URLs to find out the valid ones and store them somewhere. So it's a pretty common design pattern to do. Like if you break it down to its more abstract form, we're iterating over something, asking a question about each one, and then choosing whether or not to keep it or maybe transform it. We want to do something like this. You could do that, and that's fine. So this kind of pattern here, especially if you're just starting off in Python, we tend to find it's quite recognizable. What are we doing? We're iterating over something. We're doing some kind of conditional statement, like an if statement. And then if some condition is met, we're putting that item somewhere else. So yeah, it's a fairly common thing we have to do in Python. But if you look at how many lines this takes up, what have you got here? 1, 2, 3, 4, just for all of this. However, what we can do is do that in a list comprehension instead. And although what I do, I tend to, and this is just something I've done over time, I tend to break this down into 3 kind of main areas. We have an action, which is what are we doing with a piece of data? In this case, we're just uppercasing it. We have a source, which is where does that data come from? That's here. It comes from somewhere. So that's our source. We're iterating over this iterable. And finally, a condition. Do we want all the data, or is there a condition? In this case, there is a condition. We just want to do, length word greater than 4. Doesn't have to be. You could do this and. It's no longer than 4, but you get the idea, right? There's no condition now, so we're just doing it to all of them. And this kind of model here, this action source condition model, you can use this as the basis to form list comprehensions. So the first thing we'll do is we'll effectively copy and paste bits of this out into our first list comprehension. So the first thing I'm going to do longer than 4, I'll call this v2 here. And now let's go through and label our bits here. So I'll just make that a blank list for a second. So our action is this case here. So there's our action, the uppercase. Our source, that's here. Generally the source is that's the thing you're iterating over. And the condition is going to be our if here. And now, let's just lift it out. So start with your action. So take your action, that's just this bit here. So do this, so word.upper, for each thing in the source, so all of that minus the colon. So word.upper for word in somewheres, and actually that would work, to be honest, as it is. So if I did longer than 4 v2, without the condition, that actually works, see that? Let's go ahead and add the condition, length word greater than 4. Again, we don't need that colon here. And there we go, that's it. Let's have a look. I'm going to remove this bit here just so we can see them side by side. And there we go. Those two are exactly the same. So in this case, we've managed to transform 4 lines of creating a blank list, iterating over it, asking a question, appending and doing the word upper. You can actually just do it in a single line, and in my view, that's much more Pythonic, and also it looks a lot cooler and it looks a lot cleaner. And in case you're wondering, so a bit of background sort of knowledge on this. These kind of come from 2 families of programming styles. This is more of your imperative style, where we're doing things step by step and there's state changes, etc. This is kind of more of your functional sort of declarative style of coding, where we're essentially saying, this is all my data. And of course, the inner workings of this list comprehension go off and define what's happening. But in reality, it's just, basically, it's a for loop with, the action and the condition kind of stuck around either side of it. And there you have it. And that's your really nice, simple list comprehension. We'll take a look at a few more basic examples. So we'll clean the screen and we'll build them up from scratch. So for our next example, we'll keep it nice and simple, I guess. I want to square all numbers that are over 10. And tell you what, let's kick it off with a list comprehension to get us to that point. So to give us some random numbers, check out what we can do. If I do from random, import randint here. So randint takes two arguments. So if I do randint like that, should, maybe in your Python it will do it quicker than mine. See how it takes in A and B. Basically it gives us a random number between A and B, inclusive of both. What we can do, we can actually use that as the action of our list here. So if I do nums equals, and the action is give me a random number. Let's do 1 and let's do 25 so we get some. And now for our source, it gets a bit more interesting here. Basically, we want this to happen like n times, right? So if I did for I in range, let's say 10, we'll ask for 10 random numbers here. And just for convention, because we aren't using I here, do an underscore instead. The underscore implies that we're not using the value of I. If you were using the value of I, then you do something like that. That'll be fine because I is being used here. In this case, rewind it back, it's not being used here. So if I do print numbers here, we should see from our list comprehension, there we go. Yeah, I'm happy with that, that looks good. So we want to square all numbers that are over 10. So let's do, we'll do squared, shall we? Let's think this through. So start of your action, we want to square something. So I'm going to do I squared. There's my action done. Source, where does the data come from? Well, it comes from here. So I squared for I in nums. And there we go. So there's my action. There's my source. Next up is the condition. Over 10. So you want to do if I greater than 10. And that's it. There we have it. Let's do squared like this. There we go. So this should be different every time. Lovely. There we go. Yeah, just to recap one more time. Action, source, condition. Action at the front. Square at I. The source, well, where do those i's come from for each I in nums? So this list here. And finally, the condition. Do we want all the data or is there a condition? We don't want all the data. We just want the data that is above 10. So we do the if I greater than 10 here. Now we can take this a step further. Suppose in this case here, we want to square the ones that are over 10 and maybe half the rest here. So what we can do, we can actually take off this guy here. So if I do I squared for I in nums, let's see. Yeah, so see how that's, I'll run that again so you can see it higher up. Yeah, so I squared for I nums. So in this case here, you can see that's doing 3 squared, that's doing 4 squared. So square the ones that are over 10, half the rest. Now what you do for this is you do like a really fancy action. So you kind of do something like x, if something else. It kind of looks a bit like that. X if something else y. So what I could do I, there you go, like that. So I squared if I greater than 10, else I. Now, yeah, so if you first look at that looks pretty, I don't think it looks particularly good. But of course, over time with practice, these probably start to make more sense. Basically what we're saying, I want this if this condition holds true, but if that condition doesn't hold true, I want this instead. So if you imagine 8 going into this, I want it squared if 8 is more than 10, but 8 is not more than 10, so therefore I just want 8. So that's basically what we're doing here. So we can take this out, and we can put this guy here, like that. Now, let's hope there's no syntax errors, and let's hit run. And there we go. Look at that. So 10 and 9, 10, 4, they've all stayed the same. And of course, we've squared all the big numbers here. So you can do like an inline conditional if else at the front of your front of your comprehension. Now imagine if you'd done this without this comprehension, you're adding like 2 extra lines to an if else statement. Where actually we've got it here in a single line, which is pretty nice. You could even then stack a condition on the front as well if you wanted to. So you wanted to do a condition here, then yeah, no problem at all. Let's clear the screen again and we'll try a slightly more complicated example. Okay, so for this example, I want to calculate the pairwise product here. So we've got 2 lists, makes it a bit bigger for you. We've got evens stacked into one list. We had our odds here. Pairwise products just means like 10 times 1, 12 times 3. So we're looking at basically like the same index in both lists and trying to multiply those together here. So the way to kind of go through two things at the same time is to use the zip function. So I want to show you like the kind of rough imperative way first. So if I did for I in zip, evens, odds. I can spell odds, yeah, there we go, lovely. Print I like this. Now what this gives us, this kind of pairs together each, basically it's like doing like for I in, range len of this, and then as we look at this index, we look at the same index of the other list. That's basically doing that for you behind the scenes, which is pretty nice. We get a tuple of each item. Now, because this tuple contains two things, we can unpack it here. So if you do for I, j, now this only works because we're zipping over two sequences. If this was like evens, odds, something else, this would then be I, j, k. So if I do I and j here, rather than a tuple of each pair, we'll get each individual number represented as I and j. So if we hit run this time, there we go. So now we could do I, j, I plus j, I multiplied by j. And there we go. Yeah, 4, 15, 60, yeah, that all looks good. So to do this, we can effectively just translate this into our list comprehension. So if I just do prods for product, I guess, here. So action, in this case, it's just that, I times j. That's what we're doing. We're doing a multiplication, I times j here. Now, the source, it's, well, for each ij in, the zipped evens and odds. So, take that, and there we go. Let's throw that in the bin for a second. Prods, there we go. That's it. So let's remove that again. And there you have it, a nice simple way to calculate the pairwise product. So one more time, the action, do the product, multiply I and j. In fact, that's going to annoy me if that's not spread out. There we go, a bit neater. The source, so where does the data come from? It comes from the zipped evens and odds here, so I and j. The condition, in this case, do you want all the data or is there condition? No, there was no condition in this case. We wanted, each and every number from evens and odds. I guess you could do a condition. You could do, say, like, I don't know, maybe I want to only multiply the ones whose sum. So maybe if I plus j is greater than 0, for example. And then maybe I could do, let's see, suppose this was like minus 10 and 1. That should work, yeah. So that misses off the first one here. So only give me the product from the zipped items if they have a total which is positive. And there you go, that's it. So one nice kind of simple example. I want to finish with one that's, again, probably a bit more complex, and then we'll wrap the video up there. Okay, so for this example, we've gone with a different source. We now have a dictionary. So we have imagine this is a list of students here. Let's just call it students. We've got John, Alice, Mike, and Ian, and these represent scores they've got in a test here. Now, imagine the question is, can we create a list of passing students? So from this dictionary, which of these students have got a pass mark higher than a 50? It's only going to be Alice and Ian. Now, to do this, I suppose you could go through, you could iterate through the keys and the values. So you could do something like for key value pair in students.items. Doing this .items here basically gives you access to the key and the value. So we could say, you can even be really clever and do stu for student and then switch out the v to score like that. If I can spell scores today, there we go. So for student scores in students.items, let's keep that non-plural. If the score happens to be, we'll say greater than or equal to the pass mark, let's just print off the students. There we go, like that. Then we'll do past is equal to a blank list here. And then rather than just printing off this, we want to say, let's see, past dot append. And let's take it a step further and do a fancy F string. So we'll say blank has passed. And then inside of our kind of box here, inside our string, we're going to put stu like this here. which then means we can print off passed, and we should see like Alice has passed, Ian has passed. And yeah, that's good. Okay, this is fine. This is completely valid. However, if we want to be kind of cool and do this in a functional declarative way, let's try to identify which of these bits we can see here. So do we have an action? Yes. We are making this kind of string with each of the students. Do we have a source? We do. We're going through each student and score in the student score dictionary. And is there a condition? Yeah, there certainly is. This here. So again, just pull them apart. Action. Pinch this guy here. Source. Where does the data come from? So that's going to be this. Once again, without the colon here. And then a condition. Do you want all the data, or is there a condition? Yes, there is a condition. It's that. And there we go. Looks good. So if I now print passed, we should get exactly the same thing here. You hit clear and run to get it near the top for you. There we go. Easy. So one more time. The action is make an F string. The source is do that F string for each pair in our dictionary, but only if the following condition holds here. And there you have it. Just a heads up, as we get to the end of the video, I do a full course on functional programming. So we've got a whole lot of dictionary sets and generator comprehensions and stuff like that. You fancy having a look at that? I put a link in the description down below as well. But yeah, of course, I'd recommend if you're just starting off in Python, trying to kind of code with comprehensions right from the beginning is a really nice way of coding. It can, of course, dramatically reduce how much code you're writing. And I've just made, as a personal opinion, I think these look really cool. It's a nice and neat functional way of writing Python. Cheers for watching, guys. Hope you all have a great week, and see you all in the next session.